Hello, this is Susan Poss again. I'm still working in section 2.3, learning how to solve equations. And you can see this is the second video, so it's numbered 2.3.2. And now we're going to be looking at the multiplication or division principle of equality. It starts out, again, with two things that are equal. It says if A on the left side is equal to B on the right side, then you're allowed to multiply both sides by the same quantity. So you see me multiplying both sides by 1 over c. You can also multiply both sides by a whole number c, or you'll see me probably writing it down as dividing both sides by the number c. So again, several ways to write this, and you'll see me working some examples that use each of these techniques. So let's use our multiplication principle. Remember, our goal is to get a positive one variable term isolated on one side by itself. All right, so this one is a little different. This 4 is attached to this y by the operation of multiplication. And in order to break that operation of multiplication by 4, I need to come in with an inverse process, which of course is division by 4. And you can see once I do that, I'll be able to divide those 4's out and end up with the positive 1 y that I'm looking for. But remember, I have to maintain balance. So if I'm going to divide by 4 on the left, in order to isolate y, I have to balance and divide by 4 on the left. So this is the way I'm going to write it down. So since I see this multiplication by 4, I'm going to come in with the division by 4. And in order to maintain balance, I'm going to divide by 4 on both sides. So that's my multiplication or division principle of equality. You can see there that these 4's are going to cancel out and produce that positive 1 that I'm looking for. And here this 4 will cancel into this 32. And it looks like my answer, let's see if I can squeeze it in here. Let me put it over here, since we're sort of out of space. It's going to say 8 equals positive 1y. And that's our goal, to get that positive 1 coefficient in front of the variable y, and then some number on the other side. All right, so I'm going to skip the next one because it's very much like that one that I just did. I'm going to go down to the third one where you see 3/4 x equals 15. I told you I was going to write these in several ways. One way I like to handle working with a fraction that's attached to the variable is to come in and use a bracketing technique where I'm going to multiply by the reciprocal. I said I was going to, and then I did something else. I'm going to multiply by the reciprocal of 3/4, which is 4/3. And again, notice I'm balancing the equation by multiplying the right-hand side also by 4/3. So why would I do that? Well, the reason I'm doing that is I can see that these 3's are going to cancel out and give me 1. These 4's are going to cancel out and give me 1. And remember, my goal is to end up with a positive 1x standing alone. And then moving over to the other side, I'm going to think of this 15 as sitting over 1. And I can cancel 3 into 15 and get 5. And then multiplying across the top, I see 20. And of course, multiplying across the bottom, I see 1's. I don't need to write those down, so I'm just going to stop with positive 1x equals 20. So once again, in the next one, you see another fraction. This time the x is sitting up in the numerator. But you can think of that in the same way that you thought about the previous one. You can think of the 5/7 as sitting out there in front. I'm going to go ahead and put a bracket around this so I can multiply by the reciprocal. Now you always want to multiply by the reciprocal of the number that is attached to the variable. So I'm multiplying by the reciprocal of 5/7 because the 5/7 is attached to the variable. So you can see here the reason I'm doing that is so that these numbers will cancel out and give me that positive 1x that I'm looking for. And then over on the right-hand side, I can see that 5 cancels into 65 13 times. And whoops, there's a 1 down here now. So I'm going to go ahead and multiply across the top and across the bottom, and I see, I think, 91. And again, it's sitting over 1, and you don't need to write that, so I'm just going to stop at x equals 91. So that's the first type where we use the multiplication or division principle of equality. This next group has us looking at more than one variable term. You can notice in this first example, here's a variable term and here's a variable term, and then here are 2 constant terms. So what you're going to see me doing is searching around for those things that are alike and combining those. You see that up here in this heading above this next group. And I decided I would skip those first 2 and come down and work this third one for you. So I'm looking on the left-hand side of the equation. And again, I haven't said this prior, but I like, as these get more complicated, I like to make sure I understand where the left side and the right side break. So I sometimes put a little dotted line vertically coming down from the equals mark, trying to be sure that I keep everything on the left that belongs there and everything on the right that belongs there. So remember we talked about combining like terms? My next step is to take this 1.7y and this 1.3y and combine them into 3.0y, or just 3y. So this one has 2 steps to it. I have to combine the like terms first, and now notice that there is a multiplier of 3 sitting out there in front of the variable y. So my next step is going to be to come in here, divide by 3 on both sides, and the reason I'm doing that, again, is so these will cancel out and take me to that positive 1y that I'm interested in. And then when I do the division on the right, you'll see that I end up with positive 1y equals 2 1/10. So I would leave it in decimal form because we started in decimal form. Here's another one with the decimals in it. And again, I'm going to make sure I understand where the left side and the right side are located. And over here on the left-hand side, I see 2 terms that are alike. So let me go off to the side here. And when I combine those 2, it looks like I come up with 1x. And then I have to copy down the 2.7. It's on the left, keep it on the left. And I have to copy down the 1.3. And notice how I'm keeping the equals mark right on that vertical dotted line. All right, so another step for this one. I see 1x, which is what I'm looking for. That's good. But attached to it is a plus 2.7. So I'm going to come in with my inverse or opposite operation here. I'm going to be subtracting 2.7 from both sides. There's the 1x. I'm not going to write the 1. The positive and negative 2.7s drop out. And then I'm going to go off here, and of course you can pick up your calculator and do the arithmetic. Looks like it's negative 4.0, and I would encourage you just to write that negative 4. So we've successfully isolated the variable x. In the interest of time, I think I'm just going to do one of these, so these with all the fractions. Let me scroll down and do the second one because I think it's more difficult. So again, let me identify left side and right side with my dotted line. On the left-hand side, I see 2 terms that are both constant terms. And I need to go off here to the side. I'm going to need a common denominator. And of course, you can use your calculator to do this if you know how to work with fractions. The LCD here, I'm going to do it by hand, is 15. And I can see that in the first fraction, I have to multiply by 3 down here to get the 15, and then I balance it on top. I have to multiply by 5 down here to get the 15, and I balance that on top. So it looks like I have negative 9 over 15 and positive 10 over 15, which is going to give me 1 over 15. So this left-hand side works out to be positive 1 over 15. Let me scroll down for the second part. So I see these two variable terms. They both contain the letter y, so they are alike. I need to do some work with that. So I'm going to take this negative 5/4 and add it to 2/5. I can tell you that the LCD is 20. So times 5 down here on the bottom to get the 20, balance it on the top. Times 4 on the bottom to get the 20, balance it on the top. So now they both have a common denominator. Looks like this is negative 17 over 20. I believe that's right. Let me check my arithmetic in my head. Yep. So this side, the two like terms combine to give me negative 17 over 20y. And then careful, right here in the center is the equals mark. All right, so I'm going to use that reciprocal idea again. And I'm concentrating on the number that is sitting in front of the letter. So the negative 17 over 20 is what I'm going to try to turn into a positive 1. In order to do that, I need the reciprocal. And the reciprocal, notice it keeps the same sign. So if it's a negative 17 over 20 to start, then its reciprocal is also negative, and the numbers flip to give you 20 over 17. And of course, here I am balancing. Whatever I do on the left side, I have to balance that with what I do on the right-hand side. And of course, on the right, you'll see the 20 and the 20 and the 17 and the 17 canceling out. And notice this is a negative times a negative, which gives me the positive 1y that I'm looking for. So that's good. And then I think I need a little bit more. Maybe I can do this. Let's see. 5 into 15 is 3. 5 into 20 is 4. Yeah, I believe I can do that. So that looks like it's going to be a negative because I'm multiplying out here by a negative fraction. 4 on the top, and I think that is 51 on the bottom. And I've kind of made a mess, so let me come out here and write it a little bit better for you. So we've successfully isolated the variable y. We've made sure that it has a positive 1 coefficient on that variable y, and all the rest just falls out as you do the arithmetic. All right, so I hope that helps you to get started with solving equations in section 2.3.